Hello students, welcome to the session into distributed file systems. See, in this session we are going to deal with how the file system will be there in the execution part of our distributed environments. Right. So when we are dealing with n number of processes or else the applications, there is a need of files to be updated or called, the retrieved or to be opened or to be created and saved. So there will be n number of types where we are going to deal with the files, right? So for that, what may be the basic points we are going to discuss under the introduction part will be our today's session. So here we are going to see how the client and server architecture will be there in the file system environment. Next, what are the operations we are going to do over there, and how the cluster based distributed system will be there. And the last one is the RPC. Now, how the RPC working style will be there in the file systems we are going to see in the distributed file system environment. Now, here the client server architecture, why we are saying this point is when we are dealing few operations from client to the server, we need to know which file is located at what location, right? So there will be files remotely available, right? So this kind of things we can manage by the distributed file system concept. Now here we are going to make all the files which are transparently available in the environment to the remote clients. Right. So client will feel that I may have my file here in my system itself locally, but internally when we started with the viewing of our data, the admins who are taking care of providing that data to the client will be knowing where that file is exactly located remotely, which is there in the distributed environment, right? So this is a part of the client server architecture. Client is requesting for so and so thing, then a server which is having a file which is staying at that moment in some part will be giving the part to the client back. So similarly here also you can see one file has been moved from one location to the other location. See, file 1 moved to the client, see here. Now when client is about to ask so and so data, access are done on the client. Then when client is done, file is returned to the server back, right? So this kind of informations will be there, right? Here if you can see this diagram, this is nothing but remote access method. How we are going to take the data remotely from server to the client. And the second one is how the data to be downloaded or uploaded from client to the server. See how the data is downloaded to the client and how new file has been uploaded to the server. So this process is nothing but download and upload process, right? Here if you can see, VFS is nothing but virtual file system, where we will be in assumption that this is available to us logically, physically here, but it will be available logically in the environment. Now if a client asks for so and so file, then immediately virtual file system layer will be activated. From there you will be having the databases where that file is exactly located. Now from network file system, see, VFS is a virtual file system, NFS is the network file system. Like this we have GFS also, Google file system, right? So NFS is responsible to find your file in the network. Now NFS client will be calling the RPC client stub. See, here we need the importance of the RPC, that is nothing but you have to call your procedure which highlights that particular file, right? So stub is there to marshal the request, then from client to the server we go through the network. Now RPC server stub will be there. This stub will be unmarshal your data, means decode your request, then see what is the request sent by the client. Then my NFS server will be readily available which file system which file you need. So from the virtual file system, from the system layers, and you will have a number of locations of all the file systems with an interface with the file table, whatever we say. We will have the data and we will send back to the client over there. So this is a basic NFS file system and the structure in the Unix system environment. In Unix system, everything will be called as a file itself, right? So here see many operations we can perform, as we have seen in the outline. We are going to discuss about the operations also. Here the operations which we are going to deal with are the operation. The first one is we need to know where file is located, right? So when we are creating that file with the user data who has created, I mean the owner of that user plus the identity of the file, everything will be created at the creation phase itself. Now your file will be opened, your file will be created, and then it will be saved at one place, and you will be having n number of operations in the Unix environment to go with the command structures. You can see the list of files, you can make all the files into one folder, make directory, then symbolic link. You will be having a symbolic link, means same type of file will be available in the file system, right? Next, make node means you are going to create a particular folder over there. You can rename the file, you can remove the file, you can remove your folder. RMDIR is for removing, MKDIR is for creating the folder. Next, you can open the file, you can close the file. Lookup is nothing but if you are searching for anything, you look up a file by means of a file name. Means you are going to find the file name in not only in that thing, you are going to see in the other files also, right? Next, read dir, you can see what are the files available in that particular directory. Next, read link, get attributes of all the of that particular file, set attributes of that particular file, read and write. So to see the contents of the file, to update the contents of the file, to write something into the file. So these are all the basic operations which we are going to do on a file. So we know all this will be there in a file operations. Now see, close and look up. We are at this point, right? So we have completed with all the operations. Now in network file system, if we are in one location, if we are updating one file, in the local system we can do immediately, but in the NFS environment we have to search where is that file first of all, right? So for that kind of things we should have all the files available at one locations. So these locations we can see in the cluster based distributed file systems. Now coming to first type, this is a type of mirroring type we can say. So where we are going to have a file in one block and all its replicas also will be available over there. So like that, B, all its replicas, C, all its replicas. So like this, in the one database itself we are going to have the original file and all its replicas. So similarly, the original file, all its replicas. But the second type, which is our striping type, will be having, I have one database, whole database will be having one replica. Whole database will be having one replica. So like this, if I go access to this, I can have all the files at one single slot. That is what is a cluster, right? So if I go to this, all the files will be available in that cluster. Now like me, there are 3 users who want all the files. So parallelly they want to access. At that moment this type of information is very important. Now when there are n number of users who want only one file, so at that moment this one is very important, because user 1 connects with this, user 2 connects with the second A, user 3 connects with the third A. So like this, all the replicas also will be updated at that moment, but you must take care of the integrity part also, because the consistency is important every time. Now this is GFS client. See, coming to the GFS client, this is nothing but you are going to have all the data. I mean, GFS is another Google file system, right? In the Google file system, if we are searching for so content, immediately my master place where all the server chunks will be available. Now all the chunks are available with the file system. Now when client erases with so and so file name, so immediately master will be readily available to take what the instructions from the client and see what the client is exactly needed. Okay, so client will be giving the chunk ID and range, so that immediately in the chunk servers you will find that particular data, and that data will be sent back to the client. Okay, Google cluster of servers, we say that point as. Next, EV distributed file system. See, EV distributed file system is type where we can have all the nodes available in the rooted environment. And here you will be having the EV environment with the file systems, and file systems will be into the form of the hashed forms, right? So here the data will be encoded into the hashed forms, then that data will be saved over there, right? In the network, depending on the hashed values, you can get our data back. Okay, so this is of the EV distributed file system. Next is RPC calls in NFS. See, we decided to know about RPCs also, remote procedural calls. So as we all know, remote procedural call, client arises with one request. You should encode that with the marshalling. Client stub will be doing that. Then immediately you will send it to the network. From the network, server stub will accept that marshal data and it will unmarshal that. Then we are going to process whatever the client has requested. Then server will be giving the response in the similar way. Okay, so that happens with the RPC communication generally. Now, RPC communication in the network file system will be, client will be asking for one file. So that file, it will be looking up in the server. So lookup operates with the lookup with the file ID or is file data, whatever we are having in our hands, so that you will get the name, and from that name server will be responding. Then you read the data, read the file back to the client. So similarly here also, here you are going to read from the file system, here going to go with the procedure call. So lookup, open and read. See, immediately here we are checking the either we have file or not. First of all, yes means then we are operating read condition. Here with the procedure itself, I want so and so file and I am going to operate read operation, then write operation. So everything I am giving in the parameters over there in the procedure, then I am giving. So look up the file, open a file, read a file and then give the content to the user. So this is a form of reading the data in the NFS version 3. Next, this is a form of reading data with the RPC in the version 3. Next one is a CODA, content delivery. See, coming to the content delivery, how delivery will be happening. This is the content delivery architecture. Okay, CODA is nothing but content delivery architecture, where the data is to be delivered to the user. Okay, so here my user is a client and my provider is a server. Now, client application asked for so and so data. Now client will be sending that request to the server. Now every time this side RPC client stub will be activated and RPC server stub will be there. So only the thing is, whatever the data we are forwarding is nothing but content delivery architecture. So from server to data we are giving the data, but when we are communicating with each other, there are few side effects from the RPC client stub and RPC server stub. So that is nothing but application specification protocol will be dealing with this kind of side effects, and we can communicate directly from the client application to the server application on the top layer also. Okay, so this is a basic thing. When we have invalid states of files, how we are giving the data back to the client, we are going to see in this. See, client has been requested with some, the client has asked for some data. So server gave invalid state, that invalid state we are giving to the client, other client. So like this, the invalid, sending invalidation messages at a time. Next one, multicasting is nothing but sending invalid messages to n number of clients at the same time, parallelly. So this is one after the other. You give invalid here, then after that you give invalid to the other client. Here, give the invalid state at that moment parallelly itself. Right? So when we have outdated copies, or else when we have a file which is not there in the file system, and if you are going to read or write on that file which is not there, so all these invalid messages will be given, right? And these are few file system descriptions we need to know which are going to be operated. So control is going to control the commands, and data is about the file data. Listen is to accept incoming and outgoing request and all. Local will be providing the information about the who is asking for the data. Remote is nothing but the other side to whom we are sending the data. Status means about the file status, current status, who read it. So all this information, right? If you have any doubts in this distributed file system, Please be free to contact anytime in the college. Thank you.